Hi, in this video I have the Lalela lithium-ion home office inverter trolley, and I'm going to go through the functionality and do a little bit of testing and then give you my final thoughts. Right, this unit is advertised with a lithium iron phosphate battery. It says it is a pure sine wave inverter with a battery capacity of 960 watt hours. Right, there is the weight, 18.1 kilograms. Right, the height of the ground is just over 41.5 centimeters. The length of the unit, including the fly lead that comes out the back, is just over 45 centimeters. And the width is about 28 centimeters, depending on how this fly lead sits. Right, so the layout is there's an inverter mounted on the top of this metal cage. Inside here is their lithium battery. Now, this is where you would plug your load into. So this would be your laptop or your TV, whatever device you want to be using during the power outage. Now over here, this is where I plug in the mains. So I use the kettle type plug and I plug it in over there, and this can now be connected to my mains supply. Now that will charge the battery. And over here, we've got a battery management system terminal, which in this unit is not functional. It's there for future development. And there's also a COM port and a Wi-Fi port, which also do not have functionality on this particular unit. Right, there's a switch on the side, which allows me to power it on or to switch it off. So if I switch it on, there was a beep that confirms that it's going on, and I can hear a fan blowing. Right, I'm here at the back of the unit to get started. I first plug in the mains power cable to the back of the unit. This is now plugged into my main supply. I now can plug in my load. Here is my load plug. I'm just going to plug in a light for now. Right, I've just plugged in this floodlight as the load. Right, now I can turn on the unit. You'll immediately hear a loud fan noise, and that is present until the unit is charged. On the right hand side of the picture, you'll see that the load is powered on because the light is shining. Right, so this is the top view of the unit, and there is an LCD screen which is very important for the functionality of the unit with 4 buttons here. I'm going to go through the functionality of each one of the buttons. Right, having a look at the little LCD screen here. On the bottom here, it's got like a cell phone tower, which I think is supposed to be a pylon, and that's telling me that the utility is charging the battery and also supplying the load. This globe here, or bulb here, is the load, and notice that it's showing me the battery is charging. There's the bar graph showing me that it's currently charging from the mains. Also, look at the top left, there's a little box here that says AC and it says input, and then there's a little box here that says Li. That's telling me the type of battery. At the moment it is lithium, because this unit can be used with a lead acid battery or a lithium battery. So you can tell the inverter which battery is being used so that it can set up its charge profile for either lead acid or lithium. So in this case, it's a lithium battery. The voltage of the battery at the moment is 13.3 volts. And there you can see the sequence of the power from utility, charging the battery, and also feeding the load. Now, if I press the input button here, it will give me some more information telling me the voltage that is being inputted into the device. And there it is 226, 227 volts. So that is the input voltage I'm getting from Eskom. If I press it again, it's showing me the charge current. That is the charging current for the battery at the moment. You are able to select a higher charging current if you'd like to. You can select 15 amps or 10 amps. If I want to increase the charging current to charge the battery faster, I press and hold the input for a few seconds, and there it says charging current, and now it's changed it and it is increasing to 15 amps. So this would mean that the battery would now charge at a faster rate. If I want to lower that charging current, I press and hold the input button, and now it's changed the charging current to 10 amps. So it's going to decrement the charging current down to 10 amps. You might be wondering, why not just leave it at 15 amps all the time? Well, the reason why I don't is because if we charge batteries at a higher rate, they don't last as long. So it's always better to have the battery charge at a slower rate rather than a fast charge. But if you're in a hurry and you need your battery to be charged at a faster rate, or you don't care about the longevity of your battery, you can always increase the charging current. Now, if I press the output button there, it's telling me what the inverter is outputting to the load. And at this moment, it is the same supply voltage that is being input. And the reason for that is because the unit is running off the mains, which means that all it's doing, it is bypassing the voltage and current from Eskom directly to your load, which is there. So it is not a UPS. It's not cleaning the power. It's there as a backup power. So that means that only when I unplug the mains, like I've done right now, I've unplugged the mains, which was actually charging the battery and feeding my load. It's now offline. But look at the unit. The unit remains on. My load is still on at the back there. My load is still on. There's that floodlight. It never went off even though I unplugged the mains to the Lalela inverter. But now what is happening is the load is being supplied from the battery that is in the unit. So now there's no input to the unit. If I press input, you'll see that it says 0 volts because there's nothing coming into the unit. And notice that little AC block here, which said AC, is gone. It just says DC, and there's the battery, the lithium ion battery. So if I want to see what my load is, I press the output button. I'm getting 230 volts fed to that floodlight, my load. And additionally, it also shows the power outputted to your load. Now, in my case, I have a 50 watt LED floodlight, and there it is actually showing me that it is 50 watts. A little bit later, I am going to add additional load to get this wattage up above 400 watts, just to do some additional tests. But there you can see, you are able to see the load that is being pulled from your inverter. So at the moment, it is disconnected from the mains, and it is now running from battery. Right, so the fan has gone off because it's no longer charging the unit, and also the load that is connected to the unit is low. The manual says that the fan will only come on if the power that is required from the unit exceeds 38%, which means if the power that needs to be outputted from the inverter is over 228 watts. So at the moment, it is quiet, it is running smoothly. There is a beep every few seconds. That beep indicates that the AC mains has been disconnected or that the mains is offline. Now, if you do not want that beep to sound every few seconds, all I need to do is press the silent button here, and there it says be off, meaning the buzzer is now off. It doesn't show anything on the display here to tell me that it's off, but there will no longer be that sound of that beep every few seconds. If I want to put the beeping back on, I press silent, and notice it says buzzer on, and now that alarm every few seconds will sound telling me that the mains has gone off. Basically, it means there's an outage or load shedding. When the mains goes back online, maybe load shedding is over, the unit will automatically switch over to mains. It will then start charging the battery. There you might even hear the fan is going. You can see the pylon tower here is now indicated, and there it is now charging the battery because it has that bar graph which is growing. If the battery was low, you would see that it would be flashing on this one, and at the moment it is above 50%, probably closer to 75%, so it's just topping up the battery. If I do change the battery to a different type of battery, I can press and hold the battery there, and what it does is it changes it to a lead acid battery. So be very careful with that, because at the moment it thinks the battery is a lead acid battery just from pressing the battery for 1.5 seconds, and there it's immediately changed to the lithium. So just be aware that you are always in the correct profile. At this point I'm in the lithium profile because the battery is still lithium. I will demonstrate how to change the battery should you wish to change the battery. If you want to put a lead acid battery, or if yours arrived with a lead acid battery and if you want to swap the battery, I will show you how to open the unit and get access to that battery. Right, so to sum up, there's the input, 226 volts. There's the output, it is still 49 watts, and it is being fed from the utility now because it is plugged in and running off mains. The fan noise is present while the battery is charging. Once the battery has stopped charging, that fan noise will go away. Right, I'm now going to take some measurements and see how this device performs. Right, I have a multimeter here. It does have a graph. I'm going to confirm the voltage. I'm also going to do a test to see what happens when I unplug the mains and plug the mains back in. Over here I have my load, and each one of these globes is about 75 watts. So as I add the globes, then I'm increasing the load. One of the globes is 100 watts, but nevertheless, you'll see the wattage increase on the display of the unit. Right, so at the moment, the unit is running off the mains, but what I want to do is I want to see how well it runs off battery. So I'm going to disconnect the mains. There's the mains disconnected. And the output power is 150 watts, which is about right because each one of those globes is 75 watts. So we're looking at about 150 watts. And let's just have a look at the voltage. It says 230 volts and my meter says 227 volts. So it is quite close. The frequency is almost 50 hertz. It's 49.8 hertz. What I want to have a look at is whether it is a pure sine wave, whether the frequency is stable, and whether the voltage is stable as I load the device. So what I'm going to do now is I'm going to increase the loading. Right, so I have my loads connected. I have my meter measuring the voltage coming into the load. And according to the inverter, the output power is 427 watts. That is about right. But let's have a look at the voltage. It still says it's 230 volts. And let's see what my meter says. Okay, so the meter says it's 226 volts. The frequency is stable. It's almost 50 hertz. Let's have a look at that sound wave. The output waveform looks clean. And let's just have a look at the duty cycle. The duty cycle is an important measure to determine if the top half of the waveform matches the bottom half of the waveform. So in this case, it's 50.4%, which is good enough. Now let's see what happens if I remove a globe, put a globe back in. Remove a globe, put a globe back in, meaning I keep changing the load. Is the sine wave stable? Is the frequency stable? Is the duty cycle stable? All right, I've removed one of the globes and there was not much change at all. And now I'm returning the globe. I do hear the fan going on a bit higher, but the waveform is stable. Right, I removed the globe and I'm going to return the globe. And as I remove and return the globe, it does not make much difference to the output waveform, neither the frequency. So the output of this inverter seems to be stable, keeping in mind that these are only small changes of 70 watts. Now what I'm going to do is I'm going to switch the mains on, so I'm going to plug it in and then unplug it. Plug it in and unplug it. And I want to see if the changeover from mains to battery is stable. I'm first going to show the view of the meter, then I'm going to show the light bulbs as the load. Right, so I'm about to plug it in. Right, so the mains is now plugged in. There's the voltage, it's 231, and there's the frequency 49.85. And what I'm going to do is I'm going to unplug the mains and let's look at that waveform. And there was a little bit of noise on the waveform and then it switched back on now. Right, so there's understandably some noise when the unit goes from mains to inverter and from inverter to mains. For example, I'm now going to unplug, so I'm going to battery, so that's going from mains to battery. It should be a clean changeover, but unfortunately this is not a UPS, it's an inverter. So all that happens is it goes from mains to inverter output, and we do find these type of disturbances. Sometimes they're worse and sometimes they're better. So for example, I'm now going to disconnect the mains. Right, there was a little bit of a flicker there. Notice the lights went down a little bit, and now I'm going to plug the mains back in. And there was pretty much nothing. It was a clean switch. And disconnect the mains, and there's a little bit of a flicker there, and plug the mains back in, and that seems fine. And disconnect the mains. There was quite a big shift over there, and it really depends at what point on the sine wave the changeover took place. That determines whether there is a big disturbance or a small disturbance. But nevertheless, it is a fast changeover, and for most appliances this would not be a problem. What is nice is that the output is a clean sine wave and the duty cycle is stable and the voltage is good. I've disconnected the mains and just quickly having a look at the output, and at the moment it's feeding 424 watts. And the fan is on because, as I said earlier, if you load it above 38%, you are going to hear that fan noise. And if you're wondering how noisy that fan is, I'll quickly measure the sound pressure level. The fan noise at about half a meter from the unit is about 60 decibels. It is fairly noticeable. And the alarm beep is at about 75 decibels. The unit is running at about 430 watts, which is about 70% of its maximum output wattage because the unit is rated at 600 watts. So I've been running it at about 70 watts. So I've been running it at just over 70% its maximum power output. And I'm going to take a temperature measurement. It has been on for at least 15 minutes at this power output. The unit is running cool. It has not heated up at all. So the unit is running cool even at 70% of its maximum load. Now the specifications of the unit says it can handle 600 watts. I'm now going to increase the power output and see if I can get to 600 watts. Right, so that's 424 watts. I'm going to increase it some more. I've now added an additional 50 watts, so I'm now at 478. The fan has increased in its velocity. I'm now going to increase the output on my load. There I've now exceeded 500 watts. The unit is stable. Okay, I'm at about 550 watts. The alarm is making a sound more often now. Right, I'm at 590 watts. Let's have a look at the waveform. And the voltage has dropped down to just under 223 volts. The frequency is stable. The waveform looks good. The duty cycle is fair. On the unit, it says the voltage is 228 volts, although my meter says 223 volts. I'm going to leave it on for 10 minutes and see what happens. Right, I'm now going to load it beyond 600 watts. Right, so now I've overloaded the unit. I can hear the buzzer is buzzing frequently now. It's telling me that there is definitely an overload on the unit, and let's see what it does. The output waveform is still good, even though I'm overloading it, and the frequency is pretty much 50 Hertz, and the voltage is 223 volts. So it's actually handling this overload condition very well. However, I noticed this wire from the battery side is pretty warm. And this heat was actually quite warm already from the 70% loading. If I try to silence the alarm is now switched off. And that alarm is even switched off when it's overloaded by me pressing the silent button. Right, so now it has gone into an error. Right, so two things to note. The first one is if you've silenced the unit and you overload it, it won't override that and make a buzzing sound. So once you've silenced the unit, it's silenced even if you overload it. Now the next thing is it has gone into an error. It says EOP. Right, in the manual they show a few fault codes. In this case it is load output overload protection, error code EOP. So the instruction is to power down the unit completely and then restart it. Let's see if that functions correctly. Right, I've powered the unit down and let's restart it. Right, all the loads are back up and running, even though it is still overloaded, so it's actually pretty resilient. The inverter side of this unit is good, but it did go into overload again. So I'm going to power it down and switch it back on and let's see what happens. Right, so I'm pulling 522 watts from it now. It is not overloaded, but I am going to leave it like this for about 10 minutes. Right, it has been running for 10 minutes, but I do note that the battery cable has heated up quite a bit. It's now at 43 degrees. That is this cable running here on the side. Right, on the side here where the air is coming out from the fan, it has increased in temperature a bit, but it's by no means hot. It's just a bit warm because the unit is now running at 87% maximum load. It has been running at 522 watts for the last 10 minutes. Right, on my load test, I used a 346 watt load. It was able to run for 2 hours and 43 minutes until the inverter cut out. And then it took 5 hours and 44.5 minutes to charge the inverter with the 15 amp setting for the battery. Right, this is the inside of the inverter. The DC voltage and current arrives here on these two terminals. There's a power button over here. You can see the thick jumper from that terminal to the main board. And that's something that is concerning for me, is that these battery cables over here, in my opinion, are too thin, and I'll cover that later. So the input is here, and there is 80 amps worth of fuses there. These are two 40 amp fuses in parallel. That is quite a common setup, to use two fuses in parallel with this DC voltage. It's actually cheaper to do it like that. So if there's a fault on the inside here, this will fuse around 80 amps, depending how long the fault has been sitting there for. Now there's the output stage, there's some FETs, and overall this looks pretty decent. There's blobs of glue to assist it in terms of vibration, and I think this inverter is pretty rugged. I actually like this inverter. The display, however, in my opinion, is too dim. I'm not sure why they went with the blue color. There are the relays, so when it goes from mains power to backup power, it's just a relay that clicks over. Right, so notice that these wires are really thick, which brings my attention to this part. Now I'm going to close the unit and have a look at this and show you the battery inside. Alright, so now I want to open this to get access to that lithium ion battery. Now, the only way that I can see that I can do that is if I remove this. So the inverter is effectively placed on the top and screwed in. So I'd have to lift the inverter up, but I can't just remove the inverter because it's got this cable here. So I need to release this cable. Now I don't see any circuit breaker or anything that can stop a short from taking place here. So if you are taking out your battery or opening this for any reason, maybe your battery is faulty or you want to swap it with the lead acid battery, or yours came with the lead acid and you are installing a lithium battery, please be very careful here, because I need to undo these terminals. And because there's no protection here, I run the risk of quite a significant arc that could take place here, which could definitely damage the battery and also could be a heat risk. Now I'm going to first open that screw, and then I'm going to get some insulation tape to close the terminal here so that it cannot touch the other terminal. So I first unscrew this little lid. And now I've got to be careful here, because when I unscrew the positive terminal, I don't want to touch my screwdriver on the chassis either. So in this case, I'm actually going to unscrew the negative first. Right, so there's the negative terminal, and I'm very careful not to let it touch that positive terminal. So I'm just going to wrap it in some insulation tape now. Right, now I'm free to open the positive terminal. And I'm also just wrapping this in some insulation tape. Right, now I can unscrew the screws that are holding this inverter onto the frame. Right, I've removed all the screws around here, and I can lift the inverter off the box. Now I just need to open the fastening screws on the sides to lift this cover off. Right, so there's the lithium ion battery. It says that it can do 6,500 cycles if it was a discharge only up to 50%, and that's actually very good. And then over here it says 3,500 cycles with an 80% depth of discharge. This is the reason why lithium ion is a better option than the lead acid, because very good lead acid batteries could barely reach 1/10 of that with that type of discharge. So you can see that the lifespan should be at least 10 times what you'd get with a lead acid. I have not tested the battery. I can't say if it will meet these specifications, because this would take a few years to test. Right, so the battery is housed in the unit. It's held in place by this foam. It's not bolted down or anything, so one's just got to be a bit careful of that. And there's the positive terminal, and there's the negative terminal, and it is fed directly to this fly lead. So I do have a concern here, because we would need some form of protection here, because what happens if the user had cut this, or it got caught on a doorway when wheeling this thing, or if there was just a fault in the inverter. We need some protection for this big battery. So I'm going to have to install some protection to make sure that this is fine. So over here I have a DC circuit breaker. I'm going to cut the back of this little box and install this DC circuit breaker, so that if there's a short circuit anywhere after the battery, it will be protected by this overcurrent protection, the circuit breaker. Another option would be to install a fuse, and the fuse link could be installed right at the battery. For example, a fuse link could be installed right here at this battery to make it safe. Right, I just marked where I'm going to put the circuit breaker and the holes for the bracket, and I just need to cut through the steel. Right, I'm just using this metal bracket here to help me install the circuit breaker onto the box, onto the chassis. So I've drilled these 4 holes here, and now I'm going to feed the circuit breaker from the inside and just screw it in with this little frame holding it in place. Right, so there is my circuit breaker mounted on the unit. All right, so here I've used a thicker wire, 2 thicker wires. So this is 16mm wire, copper wire. I just covered this terminal here. I don't want it to ever be able to touch the chassis. I've added a DC circuit breaker to protect it from fault currents. So there's my DC circuit breaker. I can switch it on there, and if there's a fault or somebody shorts out the wires, that will trip. All right, so my final thoughts are that this is a game changer, because using a lithium battery will provide me with a much longer lifespan. I have not tested it to determine if it can give the 2,000 or whatever cycles that it advertises, but lithium batteries, just owing to the nature of a lithium battery, it gives more than 10 times the lifespan of a lead acid battery. So one of the biggest problems with lead acid batteries is that after 6 months, your backup time has reduced considerably, whereas with a lithium battery, that should not happen. So in this case, this is a game changer. I overloaded the unit. It handled the overload very well. It has its own overload protection. So when I overloaded the unit, it went into a protection mode and cut off the load, which was very good. I was happy about that. The unit did not run hot at all. However, when it's plugged into mains, it does get quite warm. But when it's running off the battery, it did not get warm. Just a little bit when I was running it quite hard. I let it run with a load until the battery completely depleted. and it was stable throughout the discharge time, and then I recharged it and it's good to go. So I like the unit. It's pretty rugged, and if the lithium battery lasts for as long as it's advertised, then this is great. However, I do have three concerns. The first one is the display is a little bit dark. It's difficult to read. I don't like the fact that I can change the battery technology from lithium to lead or lead to lithium so easily. That should be a little bit more difficult, just in case somebody was pressing output by mistake and they press battery by mistake for too long, and then they change the battery type without even knowing, and the little icon there, Li or PB, and it's a bit small and a bit dim. So that's a little bit of a design flaw there. When the unit is charging, I noticed that it goes from the first bar to the third. It's almost like it's very quick to get to the third bar, but then it stays at the third bar for like 3 hours. So the charge ratio of those bars seems to be out of calibration. I usually don't like these type of buttons. They tend to break around the sides and dirt gets inside there. The next critique is that the fan noise is pretty noticeable. For example, if I play it for you. So there was an example of the fan noise. It is quite noticeable if you are in the room with the inverter, but the fan noise is only there when it's recharging, so you can obviously have it in a separate room while it's recharging, or when it's under heavy load. And lastly, the unit does need thicker wires, so I've changed the wires from the ones that were supplied to these 16mm copper wires, and then any device that is connected directly to a battery, specifically a lithium battery, needs to have either a fuse or a circuit breaker, and there I've installed a 50 amp DC circuit breaker to protect that battery under short circuit conditions. Alright, thanks for watching and cheers.